All right, so let's talk mechanics, actual mechanics and anatomy, because we did that with the eye. Now let's do that with the ear. And you should be able to fill these aspects in fairly easily. But we're talking not only about the anatomy, but also the mechanics of hearing. And essentially, when you start with understanding some anatomy, you start with the biggest pieces and then drill down, or biggest parts, and then drill down into the more specific parts, or more minute parts. So essentially, out here, this area is the outer ear, and then the middle ear, which is not terribly complicated, obviously, and the inner ear. And those are the basic components. Our outer ear really is a focusing device, if you will. It focuses the sound waves coming in and focusing it down this canal, the ear canal, down onto the eardrum itself. All of this area here, this area and this area are cartilage, and this area, the gray area here, is all bone. Okay? So you have the eardrum, which essentially operates just as the name would suggest, as a drum. It translates the sound waves into vibrations that are then transmitted through the bones of the inner ear, which is the stirrup, the hammer, and the anvil, and they function by stimulating. So you see how this process works. It comes in as a sound wave across the air, translated into vibrations, and then these little these smaller areas of the inner ear translate that vibration into then another vibration or neural signal in this oval window where the stirrup actually attaches. So this is the oval window. And then, again, this is pointing to bone area. And what you see in this outer area is the auditory nerve and the cochlea. The auditory nerve is all of these processes, or all of this area here that is coming from the stirrup, stimulates the interior of the cochlea. This is auditory nerve. And then the cochlea, and it has various angular projections that manage our body in space, and it processes the information because the stirrup agitates the liquid, the fluid inside of the cochlea, and the cilia and the inner ear hair cells begin to fire as this liquid is agitated. So you have the cochlea here. The key to keep in mind when we're talking about this entire structure is that there's a lot that can actually go wrong, if you will, if you want to put it that way. And essentially, you have a variety of difficulties that arise around each of these component parts. The cochlea essentially is really the transmitting device in our ear that sends all of this information, and the neural messages essentially are going up the auditory nerve via the thalamus to the temporal lobe's auditory cortex, which we'll point out here in a second. The problems with this mechanical system causes something that we would refer to as, and let me just label this real quickly for you as we're moving in here, is where problems arise. And a lot of times you can have a variety of problems that arise, but one of them is referred to as a conduction hearing loss. Now, the key to hearing anything, and I don't mean hearing in the sense of sound waves. I mean, when you hear conduction, the first thing you should cultivate in your mind is what's conducting what, in a sense. It gives you an idea of where the problem begins to arise. So the conduction hearing loss that we refer to is damage to these hair cells that are in the cochlea. Hair cells. Or the associated nerves associating with them. So problems with the mechanical system is a conduction problem. Okay, and I misspoke. This all of this is another kind of problem. So conduction hearing loss has to do with problems in mechanics. So whether that's the bones in the inner ear, it can be any of the part that goes from the outer ear to the eardrum to the bones within the inner ear. That's a conduction hearing loss, essentially. The other kind of hearing loss we typically hear about is the sensory neural hearing loss. Hearing loss, and that's actual damage to the nerve cells or to the hair cells. So damage to nerve cells that are associated with the cilia or the hair cells themselves in the cochlea. And sensory neural hearing loss oftentimes is caused by disease. It can be caused from biological changes related to aging. It can be prolonged exposure to a lot of sound, prolonged exposure. What's interesting to note, exposure to loud sounds. What you will see, for example, at the airport, the guys that are directing airplanes always have their ears covered, partly because of that sound. But the other one is headphones. Actually, essentially, when you put something into your ear right here to transmit sound, we typically oftentimes do not adjust it accordingly to the fact that it's near. Now, a lot of us do, but a lot of people would suggest that those of us of the baby boomers that had earphones were really quite end up suffering from hearing loss, and part of that is because of the loud music we listened to. Yes, we did listen to loud music, listened to through headsets and so forth. Now, the other thing I forgot to mention to you is this interface right here. This interface is referred to as the basilar membrane, and that is the interface between the bones of the inner ear and the agitation in the area of the in the cochlear, the hair cells in the cochlea. Now, the other thing to also highlight for you is what happens with sensory neural hearing loss. And sometimes it's bad enough that we actually implant cochlear implant. We actually implant a device that will agitate, that will stimulate the auditory nerve itself, allowing to transmit electrical impulses to the brain. Sometimes you might see somebody with a disc on their scalp that is right behind their ear. That's usually a cochlear implant. The wires simply go through the cranium and then stimulate the auditory nerve directly. So those are a few of the aspects that come with the actual mechanics, where you have the outer, middle, and inner. The bones of the inner ear are really the transmitting element from the eardrum to the cochlea, the oval window and the basilar membrane, and then the auditory nerve itself, which is connected really into the cochlea and all the hair cells within it, which pick up essentially the signal itself.